This is the Ford Dearborn plant in 1962. Back in the old days, when people were still a valuable part of the manufacturing process, it was a time when people took pride in their work and pride in every car they made. As you can see right now, the production of each car began with the pouring iron into sand molds. In this video, you will see the entire production of the fourth generation of the famous Ford Fairlane. This generation was built from 1962 to 1965 at this Ford River Rouge factory complex. More than 3,600 employees currently work at this River Rouge plant. Most of them are hourly employees. In the 1960s, much more human labor was required, and the factory was much less robotic than it is today. I miss this generation of workers. They worked hard and gave us a wonderful place to grow up. As the block arrives in the engine plant from the foundry, the rough casting weighs 211 pounds. 46 pounds of this material must be machined away, some of it 1/1000th of an inch at a time. Construction of this River Rouge plant began in 1917, and when it was completed in 1928, it was the largest integrated factory in the world, surpassing the Buick City plant built in 1904. The River Rouge complex manufactured most of the components of Ford cars, starting with the Model T. Many of the cars were compiled into knockdown kits, then sent by railroad to various branch assembly locations across the United States in major metropolitan cities to be locally assembled, using local supplies as necessary. After the 1960s, Ford began to decentralize manufacturing, building several factories in major metropolitan centers. The Rouge was downsized, with units sold off to independent companies, many still operating independently to this day. They were also sold, including the famous furnaces and docks. As you can see for yourself, the workforce at that time was mostly American, men and women of all ages. Pistons are now installed quickly and deftly as the block moves on its way. The principle of car factories, invented by Henry Ford in 1913, allowed anyone to work there. Instead of working on a variety of tasks to build one car, each worker remained in the same spot and performed one task for his entire shift. The assembled engine now goes to the hot test stand where connections are made for coolant and exhaust and for fuel. Now electric power is supplied to the starter. Car bodies are welded here. The body shell begins to take form in a welding jig where side assemblies are joined to the roof. During the Second World War, the Rouge complex produced jeeps, aircraft engines, aircraft components and parts, tires and tubes, armor plate, and tractors. The old assembly plant was idled with the construction and launch of a new assembly facility on the Miller Road side of the complex, currently producing Ford F-150 pickup trucks. The body shell is moved to a second welding fixture where it is united with the floor or underbody. The frame, once a separate component, is an integral part of the unitized car body. The welding continues in order to form a strong, quiet, friction-free structure. The welding job is finished and joints are brazed. The car body is now checked and any imperfections are sanded and polished. The Ford bodies are moving on a slow-moving belt. The bodywork is now almost complete, including the bonnet and all the doors. The fourth generation Ford Fairlane is starting to take shape. A total of 7 generations of this car have been developed. Until 1961, it was the full-size class, and from 1962, the mid-size class. The successor to this car was the Ford Torino. In the 1960s, car body painting was often done by hand. Each car was an original piece. In the 1960s, American Ford was the only car company that made its own glass for its cars. You are now looking at the main assembly line at Rouge. This is where all the windows and lights were assembled and the interior of the car was worked on. As in today's automotive factories, the body was joined to the chassis frame after the interior of the vehicle was completed. The Fairlane standard inline-6 engine was the 2.8-liter, but as an option, it introduced Ford's new lightweight, small-block Windsor V8. The sports coupe option debuted mid-year and featured bucket seats and a small floor console. The trim level supplemented the Fairlane and Fairlane 500 trim levels. The 500 model had more decorative trim, such as a wider chrome stripe down the side and 3 bullets on the rear quarter panels. The engine was then assembled and connected to the Ford drivetrain. Next, the front bumper and hood were added. Bolting on all 4 wheels and adding the chrome elements was similar to today's car factories. The seats were slid in and mounted using a manipulator arm. The next stage was a thorough quality control. Here, a trained worker checked the entire exterior and interior and features of the Ford Fairlane. Then the next step in production was to adjust the lights and then test the engine performance on the dyno. Like the Falcon, the Fairlane had a unibody frame, but the body incorporated an unusual feature Ford dubbed torque boxes, 4 boxed structures in the lower body structure designed to absorb road shock by moving slightly in the vertical plane. Suspension was a conventional short-long arm-independent arrangement in front, with Hotchkiss drive in the rear. The Fairlane was initially offered only in 2-door or 4-door sedan body styles. The waterproofing of the joints around the doors and windows was now being tested. In this test, not a drop of water was allowed inside the Ford Fairlane. All the cars produced were then parked in a huge car park next to the River Rouge factory. They were then transported to their future owners across the United States. In 1964 alone, a total of 380,000 Ford Fairlane cars were produced. Let me know in the comments if you have been lucky enough to drive this car or work inside this factory. According to many owners who have had the privilege of owning this car, the Ford Fairlane was one of the nicest and most comfortable cars they have owned.
In this video, you will see how the most famous motorcycle from Kawasaki is assembled. The Kawasaki Ninja H2R. Right now, you are watching the precise assembly of the cylinders in the engine of this famous superbike. The Kawasaki Ninja H2R is one of the most advanced and powerful motorcycles in the world, and its engine manufacturing process reflects that reputation. At the heart of the H2R lies a 998 cubic centimeters inline 4-cylinder engine that is hand-built with extreme precision. Unlike most superbikes, the H2R uses a centrifugal supercharger developed in-house by Kawasaki Heavy Industries. It compresses air efficiently at very high speeds, enabling the engine to deliver over 300 horsepower. Key parts such as pistons, crankshaft, and connecting rods are made from ultra-durable alloys to withstand extreme heat and pressure. Critical engine components are cut and shaped with computer-controlled machines to ensure microscopic accuracy, ensuring every unit meets strict tolerances. The aluminum cylinder block is home to a mirror-like finish for reduced friction. Forged pistons are carefully installed with coated rings to improve wear resistance. A precisely balanced crankshaft is fitted with high-performance bearings to handle the massive forces generated by the supercharger. Titanium valves and lightweight springs are assembled to allow extremely high RPM operation without failure. The frame is made up of multiple high-tensile steel tubes, welded together in a lattice-like structure. This ensures excellent rigidity while allowing controlled flex to improve handling. Engineers carefully calculate each tube's length, diameter, and wall thickness, minimizing weight without sacrificing safety or performance. The main assembly line is where all the meticulously crafted parts of the Kawasaki Ninja come together. From the powerful supercharged engine to the aerodynamic bodywork, the process blends automation, robotics, and human craftsmanship to create one of the most advanced superbikes in the world. The process starts with the trellis frame, which acts as the main structure of the bike. The frame is firmly positioned on the moving assembly line. Before adding other parts, the mounting points are checked to make sure everything is properly aligned. The front suspension, inverted forks, and the rear swing arm are put in place. The chain drive, sprockets, and transmission linkages are then installed. At each step, digital tools are used to check that the correct torque is applied. High-performance wheels are installed first, followed by the Brembo brake systems. The ABS modules, sensors, and electronics are then carefully calibrated. The aerodynamic fuel tank is installed and sealed. Lightweight body panels, made of carbon fiber or composite materials, including the signature fairings and wings, are carefully fitted by hand. The paint is then checked under bright lights for even the smallest flaws. The advanced electronics package is connected, which includes ride modes, traction control, launch control, and quick shifter systems. Every sensor and wire is tested to ensure they work correctly and are built to last. Engine oil, coolant, and brake fluids are filled. The engine is started for the first time and tuned to meet Kawasaki's high-performance standards. Each bike is tested on a rolling road dyno to check power output, gear shifts, and braking. Hand inspections are done to ensure the fit and finish meet quality standards, with no flaws allowed. Finally, the bikes are crated and prepared for shipping around the world. Unlike mass-market bikes, the high-end Ninja models, especially H2, H2R, are produced in low volumes. Skilled technicians check tolerances, fitment, and finishing at every stage, ensuring every engine meets exacting standards. The top speed of a Kawasaki Ninja depends on the model. The Ninja family ranges from smaller entry-level bikes to record-breaking superbikes. So, the fastest Ninja ever made is the H2R, built purely for the track, capable of hitting close to 400 km/h under the right conditions. But now you are looking at the Yamaha factory in Japan. Yamaha is one of the most respected motorcycle manufacturers in the world, and its Japanese factories are known for their precision, innovation, and balance between advanced automation and skilled craftsmanship. Iwata in Shizuoka Prefecture is home to Yamaha's global headquarters and one of its main motorcycle production plants. Other locations, like Kakegawa, focus on making specialized parts, conducting research, and handling assembly. These factories produce more than just motorcycles, they also make engines, marine products, and robotics, highlighting Yamaha's wide range of industrial skills. The motorcycle assembly starts with the frame mounted on the conveyor system. Major components are added one step at a time, including the engine, suspension and swing arm, wheels, brakes, drivetrain, electrical wiring, and ECU. The fuel tank, body panels, and final details are added last. At each stage, digital torque tools and sensors are used to check for accuracy and prevent mistakes. Every motorcycle undergoes rolling road tests for engine response, braking, and handling. Sound, emissions, and vibration tests are carried out under strict Japanese regulations. Only motorcycles that pass multiple layers of inspection move on to packaging and global shipping. Yamaha emphasizes its philosophy of Ikando, creating products that bring deep satisfaction and joy. Unlike some brands that outsource heavily, Yamaha maintains a high level of in-house production in Japan, ensuring quality consistency. After assembly, every Yamaha motorcycle undergoes a rigorous testing process to ensure performance, safety, reliability, and quality. This process combines automated testing, precision instruments, and human inspection. Wheels are checked for true alignment, ensuring no wobble or imbalance. Frame and chassis mounting points are inspected for rigidity and correct tolerances. Yamaha uses vibration meters and microphones to detect abnormal noise, rattles, or resonance. Suspension components, front forks, rear shock, are checked for damping consistency and smooth travel. In 2024, Yamaha sold approximately 4.8 million motorcycles worldwide, marking a recovery from previous years. The Iwata factory in Japan produces over 22 million motorcycles annually, focusing on high-performance models. Engines are assembled in dedicated cells, allowing for focused attention and quality control. The assembly lines are designed to handle various models, with each line tailored to specific production needs. Each day, approximately 600,000 parts are used in the assembly process, with around 9,000 different types of parts involved. Automated guided vehicles are utilized to transport motorcycles through the factory, ensuring efficient movement without disrupting the assembly flow. Yamaha is transforming its factories into smart facilities, integrating advanced technologies to enhance production efficiency and flexibility. These assembly lines are designed for models with high production volumes. They are approximately 70 meters long and staffed by around 50 workers who perform specific tasks along the line to assemble each unit. The Yamaha Tracer is a line of sport touring motorcycles produced by Yamaha Motor Company. The lineup includes models such as the Tracer 700 and Tracer 900, known for their versatility and comfort on long-distance rides. Tracer 900, also known as the MT-09 Tracer, this model is produced at Yamaha's Iwata plant in Japan. This factory is known for its high-tech automated assembly lines that combine human craftsmanship with precise manufacturing technology. But now you are watching the production process of Indian motorcycles in the United States. Indian Motorcycle, America's first motorcycle company founded in 1901, produces its modern lineup at the Spirit Lake facility in Iowa. This state-of-the-art plant serves as the heart of Indian motorcycles production, where skilled technicians assemble each bike with precision and passion. Located in Spirit Lake, Iowa, this facility employs approximately 550 professionals who take great pride in each detail of the assembly process. The factory offers complimentary tours, allowing visitors to experience the bike assembly firsthand and observe the craftsmanship that goes into each motorcycle. The Spirit Lake plant is responsible for the final assembly of Indian motorcycles, including models like the Chief, Chieftain, Roadmaster, and Scout. While the plant handles the assembly, key components such as engines are produced at other facilities, including Osceola, Wisconsin. Indian motorcycle played a significant role in early motorcycle racing and innovation, including setting land speed records and contributing to military efforts during both World Wars. The bike's frame is constructed with great precision to ensure durability and performance. Engines are assembled with attention to detail, ensuring optimal performance and reliability. Each motorcycle is painted and detailed to meet high-quality standards. Rigorous testing and inspections are conducted to ensure each bike meets Indian motorcycle standards. Founded in 1901 in Springfield, Massachusetts, by George M. Hendy and Oscar Hedstrom, Indian Motorcycle is recognized as America's first motorcycle company. While the Spirit Lake facility is the primary hub for Indian motorcycle production, the brand has a global presence. Motorcycles are distributed and sold worldwide, with dealerships across North America, Europe, Asia, and Oceania.